To effectively prepare for an industrial certificate of qualification exam, a multifaceted approach is recommended. Firstly, study the code book thoroughly, whether it is the National Electrical Code, or NEC, or the Canadian Electrical Code, or SEC, depending on the location. Understanding the regulations is critical. Secondly, solve numerous practice problems and quizzes to solidify acquired knowledge and to pinpoint the weaker areas requiring further improvement. Thirdly, take simulated exams under timed conditions to mimic the actual testing environment, helping to get accustomed to the pressure and time constraints. Utilize available study materials, including textbooks and online resources, to reinforce understanding of concepts. For the Industrial Certificate of Qualification exam specifically, concentrate on understanding industrial electrical systems, equipment, and underlying principles. Dive deep into the operation, connections, and troubleshooting of transformers, motors, and other equipment used in industrial settings. Study electrical distribution systems, including circuit breakers, fuses, and protective devices. Learn about industrial automation and controls with a focus on programmable logic controllers, or PLCs, and sensors. It is important to become familiar with relevant electrical safety codes, standards, and regulations. Consider joining a study group, if possible, to collaborate with peers. Explore the option of hiring a tutor or joining a training course for professional guidance and support. Manage time effectively, ensuring sufficient time for both studying and practicing. Cultivate a positive attitude and maintain self-confidence, as believing in one's own abilities is crucial for success. The Electrical Contractors Association is a valuable resource. The Canadian Electrical Contractors Association, or SECA, offers additional support. Several other resources and materials can aid preparation. When delving into the codebook, whether the NEC or CEC, pay close attention to the articles and sections that pertain to industrial installations. The NEC Article 500 through 516. This covers hazardous locations, including classifications, divisions, and zones. Understanding these classifications is crucial for selecting the appropriate equipment and wiring methods. Study the requirements for intrinsically safe circuits and systems, as well as explosion-proof enclosures. Understand the grounding and bonding requirements for hazardous locations to minimize the risk of electrical shock and explosions. The NEC Article 430 focuses on motors and motor circuits. This includes the requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. Learn how to calculate the full load current, or FLC, of a motor, and how to size the motor conductors and overcurrent protection devices accordingly. Understand the different types of motor starters and their applications. The NEC Article 480 addresses storage batteries. This is important for industrial facilities that use batteries for backup power or uninterruptible power supplies, or UPS. Know the requirements for battery installation, ventilation, and charging. Understand the different types of batteries, such as lead-acid and nickel-cadmium, and their specific requirements. The NEC Article 670 covers industrial machinery. This includes the requirements for disconnecting means, overcurrent protection, and control circuits for industrial machines. Learn about the different types of industrial machines and their specific electrical requirements. Understand the safety requirements for machine guarding and interlocking. Focus on the transformer connections and configurations commonly used in industrial settings, such as delta Y and Y delta connections. Learn how to calculate the voltage, current, and power relationships in these connections. Understand the purpose of grounding transformers and their applications. Focus on the principles of power factor correction and the methods used to improve power factor in industrial facilities. Learn how to calculate the size of capacitors needed for power factor correction. Understand the benefits of power factor correction, such as reduced energy consumption and improved voltage regulation. Power distribution systems, including switchgear, panel boards, and busways. Learn about the different types of circuit breakers and fuses and their applications. Understand the coordination of protective devices to ensure selective tripping and minimize downtime. Focus on the principles of industrial automation and control systems. Learn how to program programmable logic controllers, or PLCs, using ladder logic and other programming languages. Understand the different types of sensors used in industrial automation, such as proximity sensors, photoelectric sensors, and temperature sensors. Focus on the safety requirements for electrical installations in industrial facilities. Learn about arc flash hazards and how to mitigate them through the use of personal protective equipment, or PPE, and engineering controls. Understand the requirements for lockout-tagout procedures to prevent accidental energization of equipment during maintenance and repair. Study the relevant electrical codes and standards. Understand the requirements of the National Electrical Code, or NEC, or the Canadian Electrical Code, or SEC, depending on your jurisdiction. Stay up to date with the latest revisions and amendments to the code. Familiarize yourself with other relevant standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. When solving practice problems, focus on applying the code requirements to real-world scenarios. Practice calculating voltage drop, conductor ampacity, and short-circuit current. Work through problems involving motor control circuits, transformer connections, and power distribution systems. Review the solutions carefully to understand the reasoning behind each step. Take simulated exams under timed conditions to get used to the pressure of the actual exam. Create a realistic testing environment by removing distractions and setting a timer. Review the exam results carefully to identify areas where improvement is needed. Focus on the topics that gave the most trouble and review the relevant code sections and study materials. Seek guidance from experienced electricians or instructors. Join a study group to share knowledge and learn from others. Attend workshops or seminars on industrial electrical systems. Consider hiring a tutor for personalized instruction and support. Maintain a positive attitude and believe in the ability to succeed. Set realistic goals and track progress. Celebrate small victories along the way to stay motivated. Remember that preparation is key to success. Thoroughly studying the code, solving practice problems, and taking simulated exams